Can you see my screen? So I think this is the question number 8. The Boolean expression in POS is f a b c d is 3, 4, 12, and 11. Okay, so what is given that we have the given the mean terms. That is sigma m 3, 4, 11, and 12. We have to find out the POS form. So this sigma m, as I already know, that is equal to the pi m 0, 1, 2, 5, 6, 7, 8, 9, 10, 13, 14, and 15. Okay. Now, can we draw it in a K-map? It is A, B, C, D. Okay. 0, 1, 2, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15. Okay. Now, can we create a 3 group? One group is this one group is this one, and one group is this one. Okay. So if we write a equation for this one, so first check which particularly variable is constant. The variable constant is b. Okay. So we have to write in the basically POS form. So when any variable value will be 1, so it will be represented as a bar, and if any value is 0, it will be represented as a normal variable. Okay, so the variable b is constant and the value is 1, so I write a b bar. Plus, for this same group, the value d is also constant. So d bar. This is the first term. Okay. If we go with the this particularly second group, this one, so a and b value is not a constant, c and d value is constant. So the value of c is 1, so it becomes a c bar, plus value of d is 0, that is a d. Okay. Along with that, this and this. So the value of b is constant, that is 0, plus the value of c is constant, that is also 0. So b plus. Okay. So this is the answer.
Sir, in this problem, we can I also create a group of second row force that is uh, 1, 5, and 13 and 9.
One, yeah, this one, na?
Yes, sir.
Yeah, you can create a group of this one, but if you see that no mean term is remaining, okay,
Sir,
like for example, I just remove all the groups. I remove this group. Okay, if you want to create a this group, this is the one group. Okay, if you want to create a this group, this is the second group. Okay, now again two mean terms, this remaining, two mean terms, this remaining. So you have to create a for this two. You have to create a group of this one. Okay, and for this one, you have to create a group of this one.
Sir,
Okay,
then we can create a corner cases also, sir, if these
corner
two
case
group
group.
are left.
Okay, so how many groups are there in that particular scenario? Four groups, no?
Yes, sir.
Okay. Now in this case, well, we have only completed into three groups. So which one is the better? Four groups creation or three group creation?
Three groups, sir.
Yeah. So that's why.
No, sir. Actually, you took R1 and R2. In row first and fourth, you took a group of four max term, na?
Yeah.
But I took four corners. Like,
Hmm. Yeah. Okay. Okay. So okay, that's fine.
yes, sir. And
So
column
is
two,
this
sir.
one corner you are taking?
Yes, sir. Right, right.
Okay.
And one
Now
group,
this group
one
you
group.
have
Yes,
create.
right. Column two. Yeah.
Okay. Okay. Now what about these two mean terms? You have to create a one more group now. So how many groups are there? One this column, two, one this one, three, and one corner. Four groups are created.
But sir,
Sir, suppose
all the max
we
terms are
can't.
covered in that.
Yeah,
All the max terms are covered in that, na?
but four groups now. Four
Okay,
groups.
matlab,
Sir,
means we have to create a minimum number of groups.
Yeah, minimum number of groups because what is the basically purpose of K map to simplify
Yes,
the expression.
simplify the expression.
Okay, why we simply expression is simplified so that the number of gates, if we implement that one, so number of gates should be minimum. Number of gates is minimum. That's why we use the K-map. No? Now, if we simplify the expression and we use four terms in place of three terms, where in the we can create a three groups, so it is sufficient. Now, why we go for the four groups?
sir, my doubt is, sir, suppose we
Hmm.
can't able to find the perfect group and we create a four group. Then
Now
that
the
four
things,
group is.
yeah, that is okay. That is okay. If you if basically like for example, you say that if this zero is not there. Hmm. In other question, not in this one. In other question, we can take that particular case also. Okay.
Yes, sir. My doubt,
Now,
it can be simplified that equation that we get from the five group and to the
so then what is the
answer that
purpose
we
of
got
K-map?
from the three group.
Then what is the purpose of K-map? If we have to solve the equations, so why we go to the
Yes, sir.
K-map?
But
K-map and both
sir,
simplification will taking both particularly same things. Okay,
yes,
you
sir. But
just
in exam, suppose I forget to take that group, then somehow I reach that answer or not. My doubt is.
uh, you can do by Excel. Like for example, if you want to verify what you have to do, like with the K-map, I just create this loop. Okay, now what for the particularly purpose in the examination part I have to verify this one. So in that particular case you just create all the groups. Now you simplify in a rough part and verify that your maximum simplification that is possible is similar to your K-map answer. If it is both are same, you can say that your answer is correct. Okay,
Okay, sir.
you can do that part in the rough work. But if we are saying that this is if we are solving or basically simplify the boolean expression after using the K-map, so what is there is no purpose of the K-map. We can solve it by our hand also.
Yes, sir. But I stuck in same this question and I created four group and I tried to simplify that four group to three group. I didn't able to do that. That's why
Oh,
I'm asking.
hmm, okay. Now in that scenario, what you have to do, I think you have to check that which particularly part will we cover.
Yes, sir, I will
Yeah.
do it. I will do it.
That is only from the practice. If you're doing the more practices, so you will solve that. There is no other particularly part of this one. Yeah, anyone is saying anything? Okay, YouTube link. Now, one more question they are asking about the practice assignment. The practice assignment question number
7, sir.
question number 7. Yeah. Hmm. Question 7. Practice assignment. A, B, C, D is equal to sigma n 0, 1, 2, 5, 9, 10, and 13 plus D, 3, 6, 8, and 12. Okay. Now we are going to do it, create it. Now in this one, you just tell me which group we have created.
So 1 second, sir.
0, 1, 2, 5, 9, 10, 13, then 3, 6, and 8, and 12. Yeah. Now tell me.
First in column 2.
First
So
corner.
first column 2, sir.
Column 2. Okay, that is a one group. Okay, good. Okay, you
Uh,
have now you have seen that one particularly column is created. Now, how many mean terms is required? 1, 2, and 3 mean terms. We have to initially focus on this mean term.
yeah.
Okay. Now,
Now the group of two, R1 and R2.
R1 and R2,
Yes, sir. R1 and R4. Row 1, row 4.
row 1 and row 4. Okay.
Group of two, sir. 1, 1 or D1.
1, 1, 1, and D. This
So
one?
1, 1, D. Sir, row 1 and row 2, group of 2, are 1, 1 and D1.
Okay. In place of this one, if I directly create a group of corners.
Oh, yes, sir. This is also correct.
Okay. If I directly create a group of corner, 1, 2, 3, 4. So any other group is required?
No, sir, because all midterms are covered.
All mean terms are covered. We are not considering the don't care conditions. Okay, it is not a consideration part. If we require that one, we can use that one. Otherwise, there is no particular. Okay.
Okay,
So
sir.
either
Okay, sir. Got it now.
now got it.
Yes, sir.
So now if we do the A, B, and C, D, 0, 0, 0, 1, 1, 1, and 1, 0. 0, 0, 0, 1, 1, 1, and 1, 0. Okay. Now for this one, C and D value will be constant. So C bar D plus. Now for the corners, in the corners first we check with the row. So row B term is constant. The value is B bar. For the column, D term is constant. The value is D bar. So this is the answer. Okay, so this is the answer.
Sir,
Any other
then
doubt?
sir, one problem also. Sir, in
Yeah.
problem 4, option 3, sir.
Problem for this one.
Yes, sir.
Okay. Kmap for the function a b c is equal to a x or b x or c. Hmm. So I just show the Kmap. A 0 1 0 0 0 1 1 1 and 1 0. So I go all four options. 1 0, sorry, 1 1 1 and 1. Okay, this is the option A. Option B is 1 1 1 and 1. A B C. Option B. Option A. Option C. 1 1 1 and 2. 1 1 1 and 1. A B C. Option C and option D. I just write here. 1 1 1 1. A B C. Okay, so first of all, I go with the option D. Okay, in the option D, what will be happen? This is the one group. Okay, the value of this group is A bar C plus. If I write in this equation and this equation, so they can create a group of 2. Okay, so for this one, the value A is 1 and the value of C is 0. AC bar. So the answer is A X or sorry, A X or C. Okay, so wrong answer. Now we go with the option B. Again, the same scenario. Create a group of these two and this one. Okay, if I create a group of these two, so it becomes a value constant 0 and C value also constant 0 plus for this group the A value is 1 and C value is 1. So that is A X not C. So also wrong option. Okay. Now we go with A option. So can I write a equation for this one? There is no grouping is possible, so we have to solve it by own. So this one is the A bar B bar C plus A bar B C bar plus this one A B bar C bar plus this one A B C. Okay. Now from these two I just take a bar as a common, so it becomes a B bar C bar plus B C bar. For these two I take a common of A B bar C bar plus B C. Okay. Now can I write it as a B x nor c whole bar, because it is a b xor. Okay, b xor c. So I'm just writing b x nor c bar. So a bar b x nor c bar plus a b x nor c, and this b x nor c I just put as a x. So it is a bar x bar plus ax. So it becomes a x nor x. And what is the x nor? Bx nor c. So it becomes a x nor b x nor c. But what we required? X or ax or bx or c. Okay, so this option is also wrong. This one wrong, this one wrong, this one wrong. Now we go with this one. 0 1 0 0 0 1 1 1 1 0. So it becomes a bar b bar c bar plus a bar b c plus a b bar c plus a b c bar. Okay.
Sir, I have one doubt, sir.
Yeah.
Sir, in the first equation, if we consider b bar c plus bc bar as a x,
Yeah.
then that whole equation will change, sir. This
Yeah.
become
Yeah.
then it depend upon our
So,
consideration, sir.
so that's why I'm saying the answer either it is a x or b or a x nor b. Both will be equal. In the week 4, we have defined a x or b or a x nor b. 3 input a x or b and
Yes,
a
sir.
x nor b both are same. For a
For
3
three
input
input
for the
gates, sir.
yeah
Yes, sir.
for the okay. So that is all up to you.
Okay,
How we
okay.
create a group? How we create a group? Like if we are creating a group in some other way. Okay, like I just create a group of these two and these two. So our equation is different. Okay, so that is all up to you how we create a group. So that's why I am saying these two are equal and this is not a wrong answer. Good. This is not a wrong answer. Now clear?
Yes, sir, got it.
Now similarly case for this one also. It is also a x or b x. If I take a bar as a common, that is a b bar c bar plus bc. And if I take a as a common, so it becomes b bar c plus bc bar. I think that is different. So okay, a bar. Yeah, I'm taking the b x or c bar plus a b x or c. Or if I take it as a bar b x naught c plus a b x naught c bar. Okay, so I take a b x naught c as a x. So it becomes a bar x plus a x bar. That is the a x or x. So it is a x or B, X, not C, I think so. If we create other groups, can we try it by creating the other groups? Mm,
Yeah, sir. In this, sir, if we try other group also, then we get the same also. Only the now place will be changed.
okay. So either this is or basically the A, X, not B, X or C.
Yes, sir.
The option A is correct. Okay. Yes. Can you tell me what is the answer of question number 5?
One, sir.
1. Okay, we can create a group of 16. Okay,
Yes, sir.
because one mean
Sir,
term
what, sir? Sir, in option, sir, A is also given and C bar is also given. These two are also possible, sir.
A is also given and C bar is also given, but the thing is that if we are creating a group, so our first priority is that our group size should be maximum. That much is possible. Okay,
Yes, sir.
if we create a group of 8, like that, that's why this question is given. The purpose of this question is only for this. We have this one. Only one minterm x. Okay. Now it is up to me. How can I create a group? If I create a group of 4, I can create that one also. Okay. If I can create a group of 2, I can create also. But the thing is that first we start with the group of 1. Okay. I just start create a group of 1. Now I just see that in place of 1, I can maximize the group by adding this particularly x. Okay. After that, I realize that I can create a group size up to the 4. That is also possible. Now I can realize that group of 8 is also possible. And finally, I realize that group of 16 is possible. So which should I consider? I consider the maximum group size. So maximum group size is 16. Okay. So the answer is 1. If you create a group of this one, group of 8, if you create a group of 8, your answer is A, but that is wrong. If you create a group of this 8, your answer is C bar, but that is also wrong. Why? Because if we have a maximum group size of 16, why should I consider the group of 8? Clear? So always the answer Y is 1. It is possible, but it is wrong. Is it now clear? So only the possible
Yes,
answer is
sir.
1. Only the possible answer is 1. If the maximum group size is possible, we should consider only the maximum group size. Now question number 6. How many groups are there?
One, sir.
Only 1.
Yes, sir. For group of one.
So only the group of these two. This one and this one. Okay. Remaining there are two don't care condition, but it is not a considerable part because we have already created a or we have already covered the mean terms, all mean terms. So one group is created. Okay, now clear? How we calculate, how we basically define the basically grouping. Any doubt you can ask me.
Sir, I was having doubt in grid assignment question number 10 and 11. Actually, they are connected only.
This week 5.
Yes, sir.
Okay, I just tell you that the question is correct or not, but I can't give you any hint before the deadline is completed.
Okay, sir.
Okay. Wait, I just check it. Yeah. F is equal to B C bar D bar plus ABC plus BC D bar plus A bar BC plus A D bar CD plus AC D bar. Is in two input NAND gate and three input NAND gate. Okay. Minimum number of NAND 2 gate is okay. So first thing is that you have to simplify the expression, or basically you using the K-map. You just simplify the final expression. After that, you just check that how many NAND gate is required. I think you get the answer. Okay. NAND 2 means is that the NAND gate with 2 inputs, and NAND 3 is that NAND gate with 3 inputs.
Yes, I simplified that, but to actually draw it, I was getting little bit. It was getting little bit tougher, so that's why I asked you. I've simplified that, but it was
You can share it with me. Okay, I will just check that. Okay, we are not discussing in the session.
okay, sir.
Any other doubts? I just check that your simplification is correct or not.
I've checked, sir, but the
No, I will
execution
I
part.
will check. I will check that if simplification is correct or not.
Okay, sir, I will send you.
Any other doubts? Any other doubt related to KMM? I just give you in the last class. I gave you some questions. Have you solved that? Related to KMF, 5 variables KMF, 4 variables KMF. I have give you some questions. Or if you want some more question to solve the KMF, basically for the practicing part, Can you tell me that one? So I just create some more questions and send it to you if you required,
Yes,
because
yes, sir, you can send it, sir.
okay. So within day 1 or 2, I will share with some more questions. Okay.
As a Boolean expression also, sir. Include Boolean, simplifying Boolean expression also using algebraic form.
Okay.
Okay, sir.
I just mentioned the Boolean expression. Okay. Okay. So I will share some more questions with you for practicing. Any other doubts?
So regarding the minimum number of gates that we can use, like NAND 2, NAND 3, or
Mhm. Okay. So give some more question related to the minimum number of gates.
yes, sir.
Okay. Anything else you want? Okay. Any doubt related to the K-map? So I just give you some questions related to this one, either in 1 or 2 days.
Sir,
Mm-hmm.
hello?
Yes.
Sir, actually, I have a doubt in last lecture, in high input, low input. Actually, I didn't understand that particular
Week
lecture.
6 or week 5?
Sir, week 5, week 5.
Okay. High input and low input.
Yes, sir.
Okay. Simply, if I am taking the NAND gate, AND gate. Okay. When the output will be 1. When both will be the 1. Okay. Both will be the 1. So we are getting the output is 1. So basically, this particularly 1 is called the high input conditions. Okay, for the NAND gate. AND gate. Now what I do, I just use one AND gate. That is the property of the IC. Okay, and here what they do, they just automatically invert that one. Automatically invert. Okay. Now, if we are giving a 0 0, we are getting a 1. Y is equal to 1. That is called the low input. Why? Because it is a property of that IC, or basically that component, that when you provide the 0, it will be automatically take a inverter of that one. Okay, and use that inverter as an input for the AND gate. Okay, so if I give the 0, so automatically the input at this position is 1. If I am given the 0, input is 1, and 1 and 1 in the AND gate will be the output is 1. So that is the basically concept in the high input and low input. That will be covered in more details in the lecture number 6. Okay. Now, why basically this particularly 1 and 0 will be considered? This is all dependent on IC technology. Like IC, or basically the component that we design, either I will design the AND gate. Okay. The basically the gates is nothing but a transistor circuit. Okay, transistor circuit. Now, in this transistor circuit, there are multiple technologies to design this, particularly either the TTL technology. I think you are aware about this one is or not. This is the TTL technology, transistor logic. Okay. Second is the RTL. There are lots of, not I am just telling 2 or 3 RTL technology, resistor transistor logic, and one is the ECL, emitter coupled logic. Okay. So in the case of TTL, what it should consider, that when we are giving no input, it should be considered as a 0, and when we're providing the high input, it will be considering as a 1. Whereas in the case of ECL, the concept is reverse. When we are giving the no input, it will be considered as a 1, and when it will be the high input, it will be considered as a 0. So basically, if you see that it is a just invert process. So what we are giving to the circuit, it will be automatically invert when we switch from TTL to the ECL family. TTL to the ECL family. So similarly thing here, when we are giving 1, so it will be automatically convert as a 0. Why? Because the family may be possible that it is the ECL. So when we are giving as a high input, so it should be considered as a 0. When we are giving the high input, it will be considered as a 0. And when we are giving the 0, it will be considered as a 1 input. Okay. So if 0, 0 apply at the input, it becomes y is 0. If 0, 0 apply at the input, it becomes 1, 1 and y is 1. Okay, so depending on the family, it will be some IC will be the active high IC or some IC will be the active low IC. Okay, that is little bit about that particularly. In week 6, it will be given in the more details. Okay, that's
Yes.
why if we see that this particularly NAND gate, this is the NAND gate that is similar to NOR gate with bubbled. But that doesn't mean that we are using the inverter. That doesn't mean that we are using the inverter to change the to flip the input. It is the automatically property of that particularly IC that when we apply the 0, 0, it will be also considered as a 1, 1. Go to the OR part, go to the OR signal, and the output will be 1.
So in that one, uh,
Yeah.
we basically know the NAND gate is and OR. So
Mhm.
NOR gate is also, matlab, you write down.
So it is a
Uh,
basically what it's a, like for example,
but
I just say A and B both are the input. Okay, so it becomes the AB bar. Now when I flip this, when I break this one using the De Morgan theorem, so it becomes the A bar plus B bar. So either I apply A and B input on the NAND gate, the answer is AB bar. Or second thing is that if we apply the A and B and invert automatically then and then using the OR gate. It is not an OR gate, it is a OR gate. So what I do, I just use the A and B, but automatically by the property of inverting low, it becomes the A bar and B bar. Now is this A bar and B bar go to the OR gate, so it becomes the A bar plus B bar, that is also equal to the AB bar, similar to this. So if input there is no
means we
bubble, it
can
is
use
a active.
means we can use this OR gate
Both are the
property instead of NAND gate.
yeah instead of NAND gate, we
Sir,
can use this. Yeah,
but we made this na actually the basic NAND, NAND gate is like that.
yeah.
But can we
Either the
use?
AND gate and not, that is an AND gate and not, AND gate and not, or we can say the not or inverted plus OR gate. Both will be giving the NAND gate.
Sir, I understand that part, but I just want to ask,
Yeah.
can we use the basic NAND gate diagram instead of this NOR, NOT and NOR gate?
Not and OR gate. Yeah. In the basically simplification part. Now, if we go with the simplification after week 6, when we simplify and basically use any expression or we basically design any circuit with the help of NAND gate, we can use this concept also. Okay, we can use that one also. No issue because our output will be same. But depends if you are using the practical implement. If you go to the practical implementation, you have to check your IC is the active low IC or active high IC. Okay.
Yes, sir.
The thing is that you go to the market, you purchase one NAND gate IC. Okay, you apply the 0 and 0 as an input and you get the output is 1. That is okay. That is the property of NAND gate is satisfied. Second, you go to the OR gate, or you go to the market and purchase the OR gate IC. Now in the OR gate IC there are two ICs available. One is the active high and active low. Okay, you purchase the active high and just give the output 0 0. You are getting the output is 0. You are saying this is not an AND gate. Why? Because you are purchasing the active high IC where it will be behave as a simple OR gate. But if you are purchasing the active low IC, when you give the 0 0, it will be giving the output as a 1. There are two different ICs are available in the market: active low and active high. Okay.
Okay, sir. I understand.
So I think that's it. If you have any doubt, you can ask. Which Sonali, which previous? Actually, better that you can write in a chat box. You can ask directly. Sir, in previous question, why not consider which previous question?
So this last one.
This one.
Yes, sir.
Which is the intermediate group? This is the, if we are talking about the intermediate group, this one.
Yes, sir.
So it is a 0, na? It is a 0. So if it is a 0, so we can't create a group of that one.
Okay, sir. Thank you, sir.
Yeah. If, like for example, this is a 1, so we can create a group of 4. This one. Okay. And suppose if this is also 1, so we can create a group of 8. There is no need of group of 4. There is a directly group of 8.
Yes, sir.
Okay. Yeah, that's it. Anything else? So I shall stop here. Thank you all.
Thank you, sir.
And just tell me one thing is that in the next two classes, I think on 23rd your quiz 1 is there, na?
Yes, sir.
Okay. So in the next two classes, you just go with the K map or basically the week 6 part, or you just want the revision of week 1 to 4?
So
So we
revision.
want revision.
Yes, sir.
Revision.
Revision.
Okay. So one thing is that can you create basically mm, put some basic like topics where you are facing the issues, that is open for all. You just try put some topics, because it is a 3 week class is remaining. Next two session, one is the 1 hour and 2 hours, so three particularly hours we have. So in 3 hours we can't cover all the particularly part. Okay, so better is that where you are facing the issue, you just drop a topics of that in a G space. So we will mainly focus on that one. If we have some remaining time, we will do the other part also. Okay, I think that is better. Yeah. So thank you all.
Thank you, sir.
Thank you, sir.
Yeah, thank you.
Thank you,